Assalamualaikum and a very good day to our respectful panel. I'm Alisha and the topic we choose is the study of Hydrocepatite in Clamshell to enhance the quality of brick. As you know, our supervisor is Ence Alexandria, anak Josh Empam. Hi, I would like to introduce myself once again. My name is Alisha binti Abdullah and my last matrix number is F1060. I will present my part, which is introduction, problem statement, objective, scope, and significance of project. So the first one is introduction. Basically, the purpose of this study is to add hydrocepatite as an additive inside concrete blocks due to the fact that concrete bricks have low compression strength and generally poor quality. Next, I will proceed to problem statement. So the first one is HAP is a calcium phosphate. So by adding it to the concrete bricks ingredient, it will expand its range of uses. The second one, the higher cost of producing concrete bricks can be reduced by replacing limestone in the ingredient with hydrocepatite, which requires no heating. The last one is at the beach, there are numerous waste shell to be found, so we can take the waste shell by using it to make bricks. So the next one is objective of this project. The first one is to determine that hydrocepatite can help to produce a better quality of concrete bricks. The second one, to produce unburned brick using shell, which is hydrocepatite as an additive. The last one, help to reduce cost production of bricks and environmental protection purpose. As for scope and significance of this project, there are 5 of them. So the first one, the strength of the bricks after adding the hydrocepatite. The second one, infiltration rate after hydrocepatite is added. The third one, comparison between burned bricks and unburned bricks. The fourth, synthesis of calcium carbonate to calcium phosphate. And the last one is the characteristic of shell used in this study.
My name is Marzatul Aini binti Marzuki and I'm going to present the literature review. The shell has calcium carbonate. The nature of that, just as lime, makes it suitable for use in construction where if shells are mixed into the bricks mix, it can increase the strength in the mixture. The calcium carbonate helps to increase the early strength due to the accelerated effect and high rate of hydration which hardens the concrete, with the calcium carbonate addition exhibits lower strength as compared with concrete without calcium carbonate, but still within the target strength. Brick is one of the most durable construction materials available. They are a low maintenance option for most types of buildings, but they are susceptible to extreme weather conditions. Building with bricks is also time-consuming and labor-intensive. Bricks are incredibly strong, known as a load-bearing materials. They are able to fully support a building. Hydrocepatite is a kind of bioceramic-based material that has been used extensively in many medical applications. Owing to nearly similar mineral contents to natural bond, the materials has been accepted as an implant in order to improve the osseointegration with the bone tissue. In this work, an alternative processing route from waste materials, namely clamshell, is in producing hydrocepatite powder is presented.
I'm going to talk about the methodology. Here's the process flow for synthesis of hydroxyapatite. Firstly, we collect the waste clamshell and then we wash till gain the white color of its surface and we left to dry. After that, we crush the clamshell using mortar fist till become fine powder. Then the powder that we gain, we heat for 3 hours at 900 degrees Celsius. After heating process, the powder that we gain is known as calcium oxide powder. This is the process flow to gain hydrocepatite slurry. 57 grams of calcium oxide powder mixed with 1 liter of distilled water and 41 mm of phosphoric acid were poured little by little into the mixture. The mixture is stirred for 30 minutes long. Then the mixture is tasted till gain the range of pH 6.5 to 8.5 pH of water. After that, the mixture is left for 9 hours. After 9 hours, the slurry can be seen at the bottom of the mixture, and the mixture at the top will remove, and then the hydrocepatite slurry is gained. Next, process flow for concrete brick. We are doing concrete brick grade 20P with ratio 1 to 2 to 4 with 300 gram of cement, 600 gram of sand and 1200 gram of aggregate. The length of mold is 21.5 cm, height is 6.5 cm and width is 10 cm. The brick sample that we're doing is sample A containing with 300 gram of HIP slurry to replace the cement ratio with 600 gram of sand and 1200 gram of aggregate. For sample B and C, both aid of 200 HIP slurry and 100 gram of HIP slurry with the same ratio of sand and aggregate.
My name is Nur Arif bin Muhammad Isfan Nizam. I will explain the strength of concrete after adding hydrocepatite. For the 7-day sample A, the compressive strength is 35.62 Newton per millimeter square. For the 14-day sample A, 43.94 Newton per millimeter square. Next, for the sample B 7-day, 24.2 Newton per millimeter square. For the 14-day sample B, 36.32 Newton per millimeter square. Next, for the control point brick, for the 7-day, 44.31 Newton per millimeter square. For the control point brick 14-day, 48.33 Newton per millimeter square. For the discussion, we can assume that the concrete brick with the hydrocepatite mixture exhibit lower strength as compared to control point brick, but it still can replace the control point brick. For example, the sample A 14 days, the strength is almost same with the control point brick 14 days.
From the result, the brick that containing 100 gram of HIP slurry in 7 days is the best concrete because it has the lower infiltration rate. The lower the infiltration rate, the good brick it can be to be commercialized. It contains of 200 gram of cement and 100 gram of HIP slurry, which means the cement function as a binder with the help of HIP slurry, make it more light and lower infiltration rate. This is the right communication of the ratio.
Here is the synthesis of hydrocepatite. Materials containing of calcium carbonate can be used to produce calcium phosphate can be found in clamshells. Chemical precipitation method can be used to produce calcium phosphate by reacting calcium carbonate with phosphoric acid. Here is the chemical precipitation method. Clamshell powder, which is calcium carbonate, is oxidized for 3 hours to remove organic matter and turn it into calcium oxide. The powder are then mixed with distilled water to transform it into calcium hydroxide. And the last one is phosphoric acid was added little by little into the calcium hydroxide slurry and stirred until it reached the pH range, which is between 6.5 until 8.5 to produce hydrocepatite.
Hello, my name is Benny Hennes Anakwani. I'm analysis the characteristic of clamshell. The clamshell we use is blood clam, or known as Anadara granosa. There was 5 group for size clamshell, but there no specific information about the size. In this project, we use group 2, size 31 until 40 mm. The chemical composite of blood clamshell, 98.7 content of calcium carbonate, 0.9 contain natrium and other components. Based on chemical compound, blood clam can use as alternative raw material for making calcium phosphate.
Hi, I'm Alicia, and I will be present the result and discussion for the third scope, which is the comparison between burned brick and unburned brick. As you can see from the figure above, it shows that concrete bricks is lighter than burned brick. As you can see, the table above shows that the burned bricks is much heavier than the unburned brick. As for the burned brick, it is 2.72 kg. for the unburned brick. As a result, sample A 2.014 kg, sample B 1.976 kg. That is the result for 7 days. Meanwhile, for the 14 days, sample A 2.049 kg and sample B is 2.011 kg.
As a conclusion, brick that contain hydrocepatite as an additive can produce better quality of brick in terms of its infiltration rate. It can be seen that brick that containing HAP slurry have lower infiltration rate than concrete brick point, while in terms of strength, brick that containing hydrocepatite slurry have lower strength comparing to the control brick point. However, sample brick containing hydrocepatite are lighter than the control brick point. It also have a whiter and smoother surface. Besides, this project can produce unburned brick that containing hydrocepatite slurry as an additive. Furthermore, by using hydrocepatite slurry, we can reduce the cost of cement if it is produced in large quantity and also achieve the objective of environmental protection purpose because we are using waste clamshell. For the future recommendation, it is better to use a burner to oxidize the clamshell for the synthesis process. Besides, XRD X-ray diffractometer should be used in order to characterize the best hydrocepatite.
Summary of cost project. We use 8 item or component. Number 1 is clamshell. Number 2 is 4 kg cement. Number 3, 22 kg sand. Number 4, 22 kg aggregate. Number 5, 70 liter distilled water. 924 milliliter phosphoric acid for synthesis. Number 7, 1 block burnt brick for comparison scope. Number 8, 3 pieces pH meter tester. The total is 125 ringgit. We use 6 block brick to test the strength of brick for strength scope. There was 2 sample A, 2 sample B and 2 control brick point. The total cost is 216 ringgit and the overall cost for this project is 316 ringgit and 55 cent.